Hey everyone, welcome who joined us so far. We're going to give it a couple of more minutes to let people join in. We're seeing people still flowing in. So take a seat for just a couple of minutes and we'll start. To whom just joined us, we're going to give it a couple more minutes and then kick it off with all the people inside. Thank you for joining us so far. See, people are still flowing in, so just one more minute and we can get started. Okay, so welcome everyone. I'm sure people are gonna join as we talk, but that's okay. We'll get it started. My name is Shachar. I'm the co-founder and CEO of groundcover. With me is Aviv, one of our most talented founding engineers, is gonna properly present himself in a few minutes. And welcome to the groundcover masterclass series. Basically, we created this series to allow each and every one of you to get a kind of a close glimpse into a few of the aspects of groundcover as an observability platform. Each time we're going to dive into a different specific aspect of the platform while trying to actually kind of follow and mimic common use cases, problems you might run into in your day-to-day life, and showing you the platform through that, but also giving you a chance to see it from the hands of the actual engineers that are building this product on a day-to-day basis, so you can ask questions about groundcover, about your environment, about general observability platforms, or anything that is on your mind, and get answers from the real people doing the actual work of building this very unique product. So let's jump right into this specific session. We're going to start off with a quick introduction of groundcover. I'm going to try and just kind of align everyone on what groundcover is, what we're doing, what we're all about, to kind of set the ground. And then we're going to jump right into the agenda of this specific session. We actually asked you guys before this session, what might be interesting, what kind of an aspect in your day-to-day life would you like to explore in this session about observability, about the pains of trying to observe complex systems. And most of you voted for microservices troubleshooting, which is notoriously known as a hard problem in cloud-native environments, in modern environments. So we're gonna dive right into that in this specific session. Aviv is gonna walk us through a very interesting use case in a microservice environment on top of Kubernetes. We're gonna try and identify a core problem and dig all the way through the root cause, and eventually even finish off by setting an alert or kind of creating a proactive action to the next time this issue takes place. During all the session, no matter what you're thinking, what is on top of your mind, feel free to stop us and ask questions, whether it's me or Aviv. We're gonna try and answer anything, and it doesn't have to be directly related to what you're seeing here. We got tons of questions in previous sessions about your specific environment, about general questions you have about your cloud or observability stack, so feel free to stop us at any time. A quick word about groundcover. Groundcover is an end-to-end observability platform that is built for the cloud. We built it so you don't have to compromise on cost, granularity, or scale while getting full observability, which is kind of the three most painful problems in modern real observability. And groundcover is powered by eBPF, which is a really unique technology we're going to talk about in a second. We've been up and running for over 2 years. We're expanding our reach and helping many customers, private and public, in like day-to-day production and end-to-end observability, and gaining a trusted user crowd that uses the system on a daily basis. And happy to see lots of these users here. So thank you for joining. Basically, groundcover provides a full observability platform, from metrics, whether it's application level or infrastructure level, traces, log management, custom metrics that you might have created that we can digest and show, Kubernetes monitoring, which is a painful problem in like the abstraction of Kubernetes. We address that heavily, and all the issues around dashboards and alerts, so you can customize your experience and build proactive actions like alert around that. We're using eBPF, one of the only platforms that actually leverage this very unique technology to collect deep observability data. Basically, groundcover has an eBPF sensor. eBPF is a technology that allows us to collect information about what your network is doing, what your applications are doing, without actually being part of the application code, which is a very unique and powerful approach. It means basically that we can monitor logs, metrics, traces, Kubernetes infrastructure monitoring, and so on, without actually being part of the applications you wrote and worked hard to create. That creates a really frictionless onboarding into a full observability platform. No code changes, full observability. And we also do that with minimal impact on CPU and memory. Groundcover was built to be performance first. Our eBPF sensor is highly mindful for the CPU and memory that we consume to actually do and provide all this observability. And we've even benchmarked it to be almost three times more efficient than other leading data collection methods from other APMs. We use a very unique architecture in the way we actually store all this data we collect with eBPF. Groundcover separates between the actual data plane and control plane. So the data plane sits in your cloud environment at all times, meaning that besides the sensor that collects the data, our observability backend basically runs on your side, so data can be kept private, under your control, and also reusable. Basically, the data never leaves your cloud environment, and groundcover has no access to it. We're built on top of the greatest and best of breed technologies for log management, log storage, metric storage, and traces storage, like Victoria Metrics and ClickHouse, that allows us to be very cost efficient, very cloud native, and also reach a very cost effectivity with storing high scale data, which means that we can also cut the very horrible bond between data storage and cost, data volumes and cost. Which, as you all know for other observability platforms, create an unpredictability in like charges and basically cost surges that you don't want to deal with. So groundcover basically completely does that to cut costs in your entire observability stack, whether it's logs or traces or anything like that, but also allows you to get all this data private and in your environment. The control plane is completely SaaS. So you experience the system as a SaaS platform, so you can easily adopt and distribute it inside the organization. Yet everything we do in the data storage pipeline is very different and unique compared to what you're used to seeing in other SaaS-based observability platforms. And the final thought around groundcover and what we do differently, besides Kubernetes and the eBPF sensor that we have fit for there, we're also built around open source interfaces like Prometheus and OpenTelemetry, so we can basically consume any log stream, traces stream, or metric stream from outside of Kubernetes in your other cloud environment. So we can easily aggregate and consolidate all the information you need from all the different aspects in your cloud environment. Whether it's cloud logs or cloud metrics, we can stream them all into one unified user experience in groundcover, where we actually correlate metrics, logs, and traces like you would expect from a heavy-duty APM, so you can easily troubleshoot, easily investigate performance issues in your system, and so on. I'm going to stop here for a second for any questions about groundcover and what we do before I kind of hand over the floor to Aviv. Anyone with any specific questions or things you would like to dig deeper into? Okay, so let's jump right into this session and the agenda that we have in store. Aviv, the floor is yours. Present yourself and show us what you have.
Thank you, Shahar. So first off, it's really good being here. It's good seeing so many people join us. And so like Shahar said, my name is Aviv. I'm a founding engineer here in groundcover. I've been with the company almost since its beginning. And today I'm gonna walk you through an issue that we actually had in our own production environment. And one of the cool things about groundcover, which I really like, is that we are able to use our own system to troubleshoot our own environment. And today I'm going to be able to show you just how that was done in a real life scenario that we had not that long ago. So you will just jump right into it. As Shachar said in the beginning, please feel free to write any questions you have in the chat during the session, and I'll try to answer them. And if I don't, then I'll address them at the end of the session. Okay, so let's get started. And I'm going to try to make the screen as big as possible, sharing. Let's see how it works.
I promise I tried.
Let's see, maybe if we, is this any better? Well, okay, perfect, good. So let me know if there's any issue as we go. Okay, so this is just jumping into the home screen of groundcover when you log into the app. And what we can see here is basically a screen that's showing us the workloads we have on our Kubernetes cluster. Now I've went ahead and narrowed it down to a specific namespace, which is called this troubleshooting example, aptly named. And looking at the list might be a bit, well, you don't know our system, right? You don't know what's going on here. So I'm gonna go ahead and show you this on our service map so you get a better picture. So opening this map tab in a new window, we can actually see a service map of the entire cluster, what's going on all namespaces, on everything. But I'm gonna go ahead and narrow it down just to the specific namespace that we're gonna look into today. And I'm gonna narrow it down even further because I wanna focus. And we're gonna look at what's revolving our few of our core components. Okay, so let's go ahead and talk about what we're seeing here. So the way, and Shachar just spoke about it, the way that groundcover works is we have sensors deployed into your production environment. Here we can see Alligator being our main sensor, which collect data using eBPF, also Kubernetes data, all sorts of ways in order to get as much context into your cluster, into what's going on in your environment. After that, those sensors will push this data, will export it into this component in the middle, which is an OpenTelemetry collector. It's an off-the-shelf collector. It's not something that we've modified. And basically everything we do is OpenTelemetry compliant. So we just push that into an OTel collector. And specifically for traces and logs, we will then push those from the collector into a ClickHouse database, which is over here. So we can see this flow here clearly in this map, which is pretty cool. And those are the components that we're going to be focusing on today. Cool. So going back to this workloads panel, we can see for each workload, and you're going to recognize some of them as collector. We have this Alligator. We can see basic data, like how many requests it is handling right now live. We can see latencies. We can see amount of pods. And here we can already see that looks like there's an issue. We can see this both because our collector is apparently restarting. We can see the amount of restarts that it had. And we've also flagged an issue here. You can see this fire sign. So like you just saw, the collector is a very key component, a core component in our architecture. And if it has an issue, if it's being restarted, that's not good for us. So we're going to go ahead and just click on this workload in order to see what's going on. So there's quite a bit of data here, but we're going to go ahead and just click on this issues tab to see, well, that's the reason we got here, right? And we can see that this container has been experiencing an out-of-memory kill. killed. So basically it ran out of memory and it died. And this happened 8 times. We can see this over here. And actually going back to the infrastructure tab, for those of you who might have already noticed, this can be clearly seen when looking at the workload's CPU and memory. Well, CPU just looks a bit spiky, but if we're looking at the memory, then we can clearly see this pattern, right? This collector accumulating memory going up and up and up and up until reaching the red line, the limit line, which is what the limit that we defined for it. And then it's crashing. It's going out of, it has no more memory to use. Kubernetes kills it. And this goes on and on and on. Okay, so this definitely does not look good. And now, if you're like me, then you're looking at this and you're basically saying, well, we've probably configured the memory limit wrong. Maybe it just didn't give it enough memory. And that's the easiest solution to think about, which also a lot of the times it makes sense, it's true. But one of the cool things about groundcover, especially about this workload screen, which I really love, is that we try to give as much context as possible on a lot of aspects. So we can look at this memory pattern. We can also go ahead and look, for example, at the amount of requests this service is handling here on the top right. And this looks pretty steady. It doesn't look like there was any spike or any increase in requests, which might have caused a burst in memory, which tipped us over the edge, which often happens. So looking both at this and also looking at the fact that the memory increase here is pretty gradual. Again, there's no spike. It takes about 20 minutes to reach the limit, and then it just dies and goes on repeat. It feels like something else is going on. And one of the best tools that we all know and love to use are logs, right? For each container, for each pod. And groundcover also collects that. There's a unique tab for logs. But again, let's stay in context. Let's continue this investigation flow. So we can go ahead and just click on the logs panel here. And now we are able to see the logs that are being collected. And if we start going through them, then we're already seeing weird things. We're seeing errors that's marked here in red. We're seeing, if we go ahead and actually deep dive in, we're seeing some exports failing, and some retries are going to happen. This was actually updated live, so we just saw some new logs. So basically, it looks like we got an error when trying to export data from the collector into our database, into ClickHouse. And we can actually even see the message here. It says too many simultaneous queries, which again feels, well, this is actually an issue when pushing data into the database. So this shouldn't happen, right? And if we go ahead and look at the logs, we're going to see this repeat and repeat and repeat. And okay, so looking at this, looking at the amount of requests, again, going back to our infrastructure pod, well, it feels like we need to broaden our view here. We need to go ahead and look at our database. And we can easily access the ClickHouse workload just by going here into the map, and we can see this the service map specifically for our collector, and we can go ahead and just click over here and open the ClickHouse workload in a new tab. Okay, so let's see what we have here. So first off, we can now see the service map from ClickHouse perspective. So you can see the collector and another, the custom metrics workload, which is very cool, and we're going to get to that in just a moment. But looking at this page, we can see that, CPU looks a bit weird, but I don't know if that's an issue. Memory looks completely fine. And why not go into the logs panel again, right? I mean, maybe we'll see something helpful there. And this is super easy though, right? You can just go between workloads, click on the logs, and just see it. And if we go ahead and look here, then this does not look good either. This looks like exceptions. There's sorry for that. There's exceptions going on here, and if we look at the logs closely, then we're gonna be seeing the same line, actually, too many simultaneous queries. We've seen that just a moment ago when we were looking at the OpenTelemetry collector. So this error is actually continuing with us between workloads. And this means that the issue is actually here in ClickHouse. So just to reiterate this very quick going through the data, we started over here. We thought that there is an issue, right? OpenTelemetry is indeed going out of memory, but it's getting more and more obvious that it is not really the collector's fault. And this is one of the most common problems, the most common challenges with microservices troubleshooting, is that they are so codependent on one another that more often than not, an issue with one service will present itself in another microservice. So we can already start seeing that, well, we need to go ahead and deep dive into ClickHouse. And remember, I just mentioned a second ago that we have this GC custom metrics workload here as well. And one of the things that groundcover does is that it automatically scrapes any Prometheus compatible data source in your environment. So you don't have to do anything. Basically, if you have a workload that is exporting Prometheus metrics, we're going to be ingesting it into groundcover as well. And then you can see it all in one place. And this is really cool because you can then go ahead and actually use, well, pre-made dashboards that are meant for Prometheus metrics that will be able to show you a lot of information. You can use, well, let's use what's already working and is common, right? So for example, if we go ahead and go into our dashboard section, this is a built-in Grafana panel. And what I did earlier, but trust me, it was just as easy as it sounds, as I went into the ClickHouse, the Grafana ClickHouse dashboard, like the official one, and I simply imported it into this environment. Just click here, new import, enter the UID, and I got this off-the-shelf ClickHouse dashboard, which connects to our data source and automatically displays all of this amazing data. And this is really good because ClickHouse is a beast of a database, but it can be pretty difficult to understand. I just saw the logs, it doesn't look very friendly, but this should be very helpful. So we have a lot of general information here, and we can see how many connections there are, but this is not too interesting. So let's go ahead and just open this queries tab. And we can already start seeing some interesting things. We can see how many select queries we had and how many insert queries we had, but we can already start seeing that, well, there are failed queries constantly. And if you're a database, you don't want to have failed queries. Specifically, there are failed insert queries, which matches our failed exports from the collector, which is trying to push data into ClickHouse. And going just a bit more down, we can see the kicker. We can see that over the last 3 hours, ClickHouse has been experiencing an average latency, a query latency of 100 seconds. Specifically, the select statements have been taking 100 seconds in average. And this is a disaster. There's just no possible way that the average select query can take 100 seconds. And trust me, this is not ClickHouse's fault. ClickHouse is a really good database. So this, well, we don't know what the bad queries are yet, but this explains what we saw before. If you go back into this OpenTelemetry collector and look at the logs again, then we're gonna see all of those logs with too many simultaneous queries. And this is a limit that was set on the ClickHouse database, the maximum amount of queries it can handle at the same time. And obviously, when we have queries that take this long, then we're going to be choking anyone else who's trying to perform anything. So basically, we have the full picture here. We have, well, almost the full picture. We know that there's let me get back to the map. We know that we have those sensors which are working correctly. They're generating data. We can actually go ahead and see this here in the APIs for the collector. We can see all those exports that are being handled at a pretty good pace. And this is data being collected and pushed into the collector. But the collector is accumulating all of this data, unable to push it further into the database. It can't insert because the database is not letting it do it, because there are some long unknown queries running in the background. And because of this, then the auto collector is actually accumulating more and more and more data, which is unable to push into the ClickHouse database, and it ends up just going out of memory and dying. And I will say, as a side note, there are a lot of ways that this could be improved regardless. Maybe we could have the collector ditch some batches, ditch data if it can't push it. You don't want to go out of memory. But this is, of course, all on the secondary degree to the fact that there is an issue with ClickHouse here. And I will say that in the real life scenario, let me remind you, this all actually happened. We went ahead and figured out what those queries were and why they were taking so long. It wasn't really 100 seconds, it was much better, but still it was too long. And we found the actual issue, which I won't be getting into here. But the main takeaway here, I believe, is indeed not thinking the first thing that you see is the real root cause. And this is especially true when there are things that are much harder to see, because finding out that there's an kill for a pod is much, much easier and will probably be displayed much faster than seeing things like this, things like how long do query take, or something, things that are more soft, more metric wise. And the last thing that I want to show you is that just like we can build dashboards, you can use build dashboards over the collected metrics, then we could also do alerts over those metrics. So if you go into the alerts tab here, then this once again is connected to your Grafana, all your Prometheus, data sources. So we can just go ahead and create a new alert rule here. We go ahead and select the specific source, and we have all of the metrics being collected here. And the specific metric that we'd like, we can, this is actually a neat trick. You can just go ahead and this is, let's say that we want to see if queries are taking, if the average select query, for example, is taking more than some time, then we could just go ahead. We could obviously go ahead and read the ClickHouse documentation, which will tell us which metrics to use. We could also just go ahead and see what's going on here in this panel. Here we can see the calculation that's going on. We can just copy paste this, put it over here. We will need to remove this instance filter just because it makes sense in the dashboard. It does not make sense here. And if we go ahead and run this query, we can see the data already here. This is in microseconds. I don't think that we want to work with microseconds, so we can just go ahead, and this is just a prompt UL, right? Divide this by 1,000,000 to get this in seconds, and now it looks like the graph that we've seen before. And then this is just a standard Grafana alert. We can go ahead and select, for example, if the mean value of this is above, for example, I don't know, 50 seconds. You can see this happening here. Then this is our alert. And this alert then connects to whatever platform you want. You can do this into Slack, PagerDuty, email alerts. And we can set this up, and then at least the next time we'll be able to realize there's a problem with ClickHouse and investigate it from the beginning and not waste our time, in air quotes, about the collector. Yeah, that's it. And groundcover, we also have those alerts now in our own systems. We've learned from our mistakes, and we are much more aware of long queries and are able to optimize and catch them faster, so that, of course, we are able to continue collect data without any interruptions for our customers.
Thanks, Aviv. That's super interesting. I think it also shows how eventually, one observability platform that can consolidate logs, metrics, and traces can really help you figure out things better. I mean, you just correlated, logs from different microservices, traces that build a dependency map, all the way through to metrics from the different parts of the system to actually figure out what's going on. And this is a 4-component problem. I'm sure people here in the audience have seen even worse than that, and that took us a while to figure out. So eventually, I think that it just shows how complex these problems can really get. We're gonna stop here to get any questions from you guys about anything of the things you saw here. Any questions for Aviv, about groundcover, about what you just saw, about what we collect, about anything like that? Anything you would like to know for the next session, or if you decided that you haven't had a chance to see here that you want to touch on or cover? Gonna give it just one more second and tell you during that we're gonna do another one of these sessions really soon and cover more of the aspects of the system to show you more troubleshooting cases. We have one alert. I'm already inside the system. We have one question of what protocols are supported with eBPF today in groundcover. Aviv, you want to take this?
Yeah, of course. So today we are supporting HTTP and gRPC, MySQL, PostgreSQL, Kafka, and Redis, and DNS. We also support encryption for all of those protocols. So it doesn't matter if you're using HTTP or HTTPS, you're going to be able to see everything automatically without having to change a single line of code.
I'll add to that we have lots more coming up in the next few weeks in our roadmap, but we also see that these are the things that we're seeing in customers that we worked with today. I think we have another question. I'll just finish what I started before. We're gonna do another one of these every couple of weeks. So you guys feel free to suggest any topics in our Slack community. If any of you here aren't in our Slack community, please join in. I'm gonna send you in a second. Great question again about protocols, about AMQP. It shows the map isn't connected. Aviv, wait a second. With AMQP, it shows the map not connected. I'm not sure I completely understand the question. Perhaps Aviv, you can try to help me here.
Yeah, so first off, I've sent there's a section on our docs about supported technologies. So you can also look over there. And I'll answer both questions together. So if I understand correctly, for example, for AMQP, which we are, well, both AMQP and Mongo, actually, which are both planned to be supported on a roadmap, currently will not be collected and displayed. So you will still be able to see everything that's infrastructure, everything that's metrics, that's custom metrics, logs, Kubernetes events for workloads which are using those protocols. In the future, after we add the support, you will also be able to see those like the rest on the map, on the traces section, which I haven't gotten into today, but it's also a really cool section. Yeah.
Yeah, we have another question of how to store things that we collect basically in ClickHouse and Victoria metrics in object storage like S3. So we can tell you about the connection between ClickHouse and S3. Aviv, would you like to explain a bit about that? So I can tell you in the meantime that for ClickHouse, we know how to offload basically the logs and traces we will collect, the events we will collect in ClickHouse into object storage, which I know some of you are concerned about regarding costs. Our documentation still doesn't completely explain all that through, Luis, so we'll definitely take care of that really soon. And if you have specific questions around that, feel free to reach out and we can also do a quick session on that. For Victoria metrics, it's currently not supported, but it's going to be supported quite soon, I assume. What are the cons of using eBPF compared to Datadog libraries, Aviv? This is a good question.
Yeah. Well, I would say that it's mostly adding support, like you just asked, because Datadog libraries has the context in which you are using them. So you as a developer, you know that you're now using Mongo, for example. And with eBPF, we have to do all the hard work to identify that by ourselves in order to generate this context. But honestly, other than that, it basically outperforms everything. You don't have to change a single line of code. You don't have to do anything as a developer. It outperforms it in terms of impact on your application drastically. It's nowhere close. And
yeah, perhaps we can share in the meantime. We can continue talking a bit, and I'll share the benchmark log. Perhaps it can also give another aspect into this question.
Yeah. And yeah, I would say it's much easier to maintain. It's harder for us to maintain eBPF code, but it's much easier for you because you don't not eBPF code, but your environment, as you will never have to. If you have a new service, if someone starts a new service, then you don't have to do anything. It will just automatically appear. It's in a matter of moments, actually.
We also shared the link here of joining in our Slack. We have a community Slack where you can ask questions, get our announcements. We know a lot of you are concerned about product roadmap, where we're going, what are the next features. To anyone of you who've tried out groundcover, you know that we deliver features pretty quickly. So we'll try to be more clear on that and let you know about release changes and upcoming roadmap. So stay tuned in the community. I think we have another question coming up, so we're gonna give it one more minute. Thank you, Jaron, about your support. eBPF, just to kind of mention it, groundcover doesn't own eBPF. eBPF is a great technology. It's open source. You should definitely try it out regardless. I think what we do is push it to the limits regarding APM sensors, and but it's definitely a really interesting technology. Any more questions from you guys about anything else you saw here or want to see? Yeah. So thank you, Louis. Yeah, and we do believe that. I mean, no disrespect to OTel, we believe that the protocol behind OTel is super important for the community, and groundcover supports it, and we integrate with OTel in every possible way. If you guys have instrument OTel and did the hard work, we're going to support you there too. But yeah, definitely try eBPF to collect data where you haven't. Thank you, everyone, for the time, and thank you for all the questions. Aviv, thank you for the mind-blowing demo and for your time. And we're going to see you guys again in a couple of weeks. Feel free to suggest any topics before that so we can better fine-tune the session to what you're looking for. Eugene, I'm going to give you a second to ask the question. Oh, thank you. So thank you too. Aviv, do you want to add anything?
Yeah, I just want to say it's been a pleasure, and feel free to hit us on Slack, on our community Slack, ask anything, eBPF or anything else wise. We love talking about it. So yeah.
Thank you, guys. Bye, everyone. Have a great day or great night.